Hi guys, welcome to another video. So today we've got an analytical problem. Let's do it together. So it says study the diagram. This diagram is not drawn to scale, and answer the questions that follow. So in the given problem we are presented with a triangle ABC, and we should bear in mind that this triangle is not drawn to scale. So the first question says determine the length of AB. So we need to determine the length of this line. So in order for us to determine the length of AB, we need to apply the distance formula. That is AB is equals to XB minus XA the whole squared plus YB minus YA the whole squared. So we can just substitute. This is equal to the square root of XB, which is 3 minus XA minus 5 the whole squared plus YB, which is 2 minus YA 8 the whole squared, and this here is equals to the square root of 3 minus 5, which is 3 minus negative 5, which is 8 squared, plus 2 minus 8, which is negative 6 squared. So this is equals to the square root of 64 plus 36, which is equals to the square root of 100, and this is equals to 10 units. So the next question says determine the midpoint of AC. So they want us to find the midpoint of this line, so we need to apply the midpoint formula. So capital M, the midpoint of AC, is equals to XC plus XA over 2 YC plus YA over 2. So now we can just substitute. XC in this case is minus 3 minus plus minus 5 plus minus 5 over 2, and YC is negative 2 plus plus YA is 8 over 2. So we can just simplify that. So this is equals to negative 3 minus 5 is negative 8 over 2, and negative 2 plus 8 is 6 over 2. So this is equals to negative 4 and positive 3. So moving along, they want us to determine the equation of BC. So they want us to find the equation of this line. Notice that this line has a positive slope, so we expect our gradient to be positive. So to find the equation of that line, we have to first find its gradient. So let's start by writing the equation for the gradient for BC. Small letter MBC is equals to change in y, which is YC minus YB, over change in x, XC minus XB. So now we can just substitute. YC is negative 2 minus YB is minus 2 over XC is negative 3, and XB is minus 3. So this is equals to negative 4 over 6, negative 6, which is equals to positive 2 over 3. So we know the standard equation for a straight line is y is equals to mx plus c. So we've already established the gradient to be 2 over 3, so we can substitute it into the standard form. So this is 2 over 3 x plus c. So now we can substitute the coordinates of B or C into the equation to find the value of C. So let's use B. So when the output is 2, the input has to be 2 over 3, and x is the input, which is 3 plus c. So 3 and 3 cancel, so 2 is equals to 2 plus c. Therefore c should be equals to 0. So this implies the equation of line BC is equals to y is equals to 2 over 3 x plus 0, which is just y is equals to 2 over 3x. So moving along, the next question, prove analytically that AC is not perpendicular to BC. So we need to show that BC and AC are not perpendicular. To do that, we need to show that the gradients of their lines, the product of the gradients of their lines is not equals to -1. So we've established the gradient of BC to be 2/3. So we need to still find the gradient of AC. So let's apply the gradient formula. So the gradient of AC is equals to change in y, which is yc minus ya, all over xc minus xa. So we can substitute yc is -2 minus 8 all over xc, which is -3 minus -5. So this is equals to -10 all over -3 plus 5 is +2. So this is equals to -5. So we can test. Let's find the gradient, the product of the gradients. That is MBC multiplied by MAC is equals to 2/3 times -5, and this is equals to -10/3, which is not equals to -1. Therefore BC is not perpendicular to AC because the product of their gradients is not -1. Instead, it's -10/3. So let's have a look at the last question. It says determine the coordinates of D such that ABCD is a parallelogram. So let's include point D on the sketch. So we can imagine that D, one of the coordinates, and we need to find the coordinates such that ABCD is a parallelogram. So let's also consider the diagonal DC. Let's call it M. So one important property of a parallelogram is that the diagonals bisect each other. So in other words, for the given parallelogram, the midpoint of AB is also the midpoint of CD. These two diagonals share the same midpoint. So we can use that property to find the coordinates of D. So let's start with finding the midpoint of AB by applying the midpoint formula. So we can say the midpoint of AB is equals to XB plus XA over 2 and YB plus YA over 2. So this is equals to XB is 3 plus minus 5 over 2 and YB is 2 plus YA is 8 over 2. So this is equals to 3 plus 5 is -2 over 2 and 2 plus 8 is 10 over 2. So therefore the midpoint of AB is equals to -1 and 5. So the coordinates for M is -1 and 5. And since these lines or these diagonals AB and CD share the same midpoint, we can use the midpoint formula once again to establish the coordinates of D. So we can say the midpoint of DC is equals to the midpoint of AB, because this holds for a parallelogram, and this is equals to XC plus XD over 2 YC plus YD over 2. So now we can substitute XC is negative 3 plus xd over 2, and yc is negative 2 plus yd over 2. And since we've already established the midpoint to be negative 1 and 5, and since these two diagonals are equal, it implies that their coordinates are also equal. So we can equate the x coordinates and the y coordinates to find xd and yd. So we can start with the x coordinates. We can say negative 1 is equals to negative 3 plus xd over 2. So we can cross multiply. Negative 2 is equals to negative 3 plus xd. Therefore, xd should equals to negative 2 plus 3, which is equals to positive 1. So I'm just going to replace xd on the schematic with positive 1, and the same can be done with the y coordinates. So for the y coordinates, we see that 5 should be equals to negative 2 plus yd over 2. Once again, we can cross multiply. 2 times 5 is 10, is equals to negative 2 plus yd. Therefore, yd should be equals to 12. So I'm just going to replace y with 12. So the coordinates of D is 1 and 12. Thanks for watching. See you in the next one.